Welcome to Hart und Trocken. My name is Dirk Schiborn, and in this video I want to walk you through a practical example where we create SQL queries on a relational database which could be used in a web shop. The database we use is called product for product data and consists of 4 tables: customers, orders, products, and deliveries. The customers table stores information about the customers of the web shop. One dataset representing a customer consists of a customer ID, the name of the customer, the city where the customer lives, and since when the customer is a customer of the web shop. We skip the table orders for a moment and look at the table products. The table products stores all products which are offered by the web shop. A dataset representing a product consists of the product ID, which is called prod ID, the name of the product, the variant of the product, and the price. Note that the existence of the attribute variant indicates that each product comes in several variants. So to precisely identify a product along with its product variant, we need to specify the product ID and the variant. We will have to keep this carefully in mind when we use joins along with on conditions in our queries. Then there is the table orders. The table orders stores all orders which have been placed by a customer at the web shop. One dataset in the table orders consists of the order ID, the customer ID, that is the ID of the customer who has placed this order, the product ID along with a variant, that is the specific product variant which has been ordered in the order, the quantity, which is the number of items of this product variant which have been ordered, and order date, which is a timestamp of when the order has been placed. As we will later see, a customer can order different product variants within one order. As one dataset in orders contains the attributes product ID and variant only once, for each additional product variant within one given order, an additional dataset in orders has to be created. So for instance, if one order contains 4 different product variants, the order consists of 4 datasets within the table orders. So the table orders stores information about which customer ordered which product variants in which quantities at which time. The 4th table in the product database is the table deliveries. It stores information about how long an order took to be delivered to the customer. One dataset of deliveries contains the order ID, that is the ID of the respective order, and the number of days, which is the time which was needed to deliver the order. Now, after having understood the structure of the product database, let's make ourselves familiar with its contents a little. As you see, I've opened SQLite Studio and loaded the product database into SQLite Studio, as you can tell here from the databases list. You see the 4 tables: customers, deliveries, orders, and products listed here. And if I double click on one of these tables, we see its structure is displayed. And if I click here on the data tab, we can see its content. So in this case of the customers table, you see the customer's ID, customer's name, the cities where they come from, and since when they're customers of the web shop. Similarly, if I double click on products, we see the datasets contained in the products table. If we have a closer look, we find that there is something special about the product ID. And this is the fact that we can have multiple datasets with the same product ID. They also have the same product name. The reason for this is the variant. As I told you before, a product is only specifically defined if we also specify the variant. So that means for the product F0FYI with the name Sabor de Soledad, we have 4 different variants. Only the information about the product ID or the product name along with the variant which we want is the complete information we need to specify a product variant. That is especially important in cases where the different product variants have different prices, which is the case for instance here for the product Flubber. Let's look at the orders table. A dataset consists of the order ID, the customer who had placed that order, the product ID of the product which has been ordered along with a variant, the quantity, how many of them have been ordered, and the date when the order has been placed. Now, as I said earlier, it is possible to order different product variants within one order. This is why here we also have multiple rows with only one order ID. You see that they also carry the same customer ID and the same order date. The three things which are different are product ID, variant, and quantity. So we can think of these 4 rows as being one order with this ID, this customer, and this order date. And the items which have been ordered in this order were 4 times this product in the medium variant, 2 times this product in the NA variant, 5 times this product in the deluxe variant, and twice this product in the special variant. So here you see that the variant information sometimes is not available. In these cases, the attribute variant takes the value NA. Finally, looking at the deliveries table, we find the order IDs along with the day's information, the information of how long the order took to be delivered. As you can see, for some order IDs, we simply don't have this information, which is why the value null is contained in the days attribute. Now suppose you are the owner of the webshop who is running the product database and you are interested in different information about your customers, your orders, your deliveries, and so on. You phrase the information you are interested in requests using natural language, and they now have to be translated into SQL. We will work through a couple of examples where we do this translation from natural language into an SQL query based on the product database. The first one is this one. Select customer names and the amounts they ordered for those who ordered more than 5 items. Now, the first thing we do when translating such a natural language request into SQL is to determine the tables which we need to retrieve the information. In this case, it's apparent that we need the customers table because we're supposed to select customer names. We are also supposed to identify the amounts they ordered in the case that they ordered more than 5 items. Now, the information about the amounts they ordered is contained in the field quantity in the table orders. The information if they ordered more than 5 items or less is also contained in this attribute. So apparently, to retrieve the complete information, we need the tables customers and orders tables. That means we have to create a join of these 2 tables. Whenever we create a join, we have to think about the write on condition, which ensures a meaningful match of rows coming from customers and rows coming from orders. In this case, obviously, we want to combine an order with a customer who has placed this order. So the on condition needs to match the attribute customer ID from the table customers with the attribute customer ID from the table orders. So we write on customers dot customer ID equals orders dot customer ID. Now let's switch over to SQLite Studio in order to build the complete query. So for creating our query, we open an SQL editor window by clicking on the little paper and pen symbol up here. Now what are we supposed to do? We're supposed to select the customer names and the amounts they ordered for those who ordered more than 5 items. Let us start by writing down the join and the on condition, which we have already figured out, which is customers join orders on customers customer ID equals orders dot customer ID. Next, let us specify what we want to select. So let's create a line above this and type select customer's name and the quantity. So orders quantity from customers join orders on customers customer ID equals orders customer ID. Now I want to point out that in front of the attribute name name, I put the name of the table where it comes from, which is customers, using a dot symbol in between. Also, in front of the attribute name quantity, I put the name of the table where it comes from, which is orders. Actually, when joining 2 tables, we only need to do this extra specification of the table where it comes from in cases where the name of an attribute is not unique. More specifically, if the name of the attribute occurs in both of these tables. In fact, this is not the case for either of the attributes name and quantity. But for reasons of clarity and transparency, I prefer to always put the table name in front of an attribute's name. Now, are we finished? Well, not quite, because it says select customer's name and the amounts they ordered for those who ordered more than 5 items. For those who ordered more than 5 items. This is, we have an extra where condition, and we have to select only those who ordered more than 5 items. So how can we do that? Well, how many items have been ordered is also contained in the quantity information. So orders.quantity is the attribute we have to look at. And that should be, well, more than 5 items. That means that should be strictly greater than 5. And there we go. That's it. Select customer's name, orders quantity, from customers join orders on customers.customer_id equals orders.customer_id, where orders.quantity is strictly greater than 5. Let's execute that. So we get those. And we first confirm that, well, the quantity is everywhere strictly greater than 5, so that's fine. And we got the name and the quantity, and well, it looks good. Now I want to point out something which is a little subtle. Remember that before, when we examined the contents of the table orders, we discovered that one order actually consists of a couple of rows. That means all rows which carry one and the same order ID. Now, if I think as an order as taking all rows together which carry the same order ID, the number of items which have been ordered in this order is the sum over all these quantities here. So we actually should group by order ID and then sum up all these quantities. However, in the query we have just created, we did not think of an order as being multiple rows. We rather interpreted one order to be one data set in the orders table. That, admittedly, made things a little easier. But that was the warm-up. And in our next exercise, we will look at an order in exactly that way of being multiple rows in here. So in our second exercise, we want to find out how much each customer ordered in each of his orders. And as I've just said before, we now interpret one order to be all rows in the orders table which carry the same order ID. Let's figure that out in SQLite Studio. Again, we start by identifying the tables where our information comes from and joining them in a meaningful way. As we are supposed to find out how much each customer ordered in each of his orders, all information we need come from the tables customers and orders. So actually we have to do the same join as we did in the example before. So we write customers, join orders, and now the on condition matches the customer ID attribute in customers with the customer ID attribute in orders. It's useful to expand the table names over here on the left-hand side in order to always know which columns the table contains and how they are exactly spelled. So we expand customers and orders. So as I said, it is customers.customersid equals orders.customerID. So now let's think about what we are supposed to select. So I clear that row above and type select, and then what are we supposed to select? So it says now find out how much each customer ordered in each of his orders. So obviously we need the name of the customer, which is customers.name. So what else do we need? Well, it says how much he ordered in each of his orders. The how much information is contained in quantity, and the quantity attribute is contained in the orders table. So we're supposed to select orders.quantity. Let's see if that is the right selection, but let's keep it like this for a moment. Now we add a from and think about what else we need. Well, as I said before, we think of one order to be all data sets in the orders table which carry the same order ID. For this purpose, it would be handy to divide the complete orders table into groups according to the different order IDs. Well, this can be achieved by the group by command. So after the join, I type group by, well, orders.order ID. Now, before we continue, I want us to really understand what this line group by orders.order ID really does. In order to do that, I undo this line by deleting it and add another attribute up here in the select area, And this attribute is orders.orderID. So why do I want to also select orders.orderID? Well, because I want to be in control of the attribute I will later use for the group by. So let's see what that gives. Here you see, well, it's a long list of names and quantities and different order IDs. So what I want to do now is I want to order by that order ID here by clicking on this. And this is what we expect. We see that for many order IDs, we have multiple rows with the same order ID. So as we said before, actually these 3 rows represent one order. In this order, different items or different products and their variants have been ordered with these quantities. So because we want to know how much each customer ordered in each of his orders, we actually should take each unique order ID, collect all rows which contain this order ID, and sum up all the quantities in these rows. Now let's reinsert the group by line, group by orders.orderID, and let's see what we get. Now again, we have a list of name, quantities, and order IDs, but if I sort by order ID now, you see that each order ID is unique. The reason for this is that SQL has built groups according to the different values of order ID. So it went through the complete table orders, took each value of order ID it could find, and collected for each of these values all rows with this value, and build a group from these rows. So what we see here are the groups. So this row stands for one group, this row stands for one group, and so on. Now one point which is extremely important to understand is that the other attributes, apart from order ID, which we select here, need to be the same for all datasets which are in one group. So we have to be sure that, for instance, in the group with this order ID, every dataset which is contained in this group has the name Horst Eckel. Because suppose there are 2 or more datasets within this group with different names, then it's not perfectly specified which of these names should be chosen by SQL. It will output a name, but we can't control if this is the right name, and actually the question is not posed well. Because if we ask for a name within a group, we must know that that name is unique. But actually, the problem I'm talking about regarding the name is not a problem at all. Because if we have a look at the orders table, just open the orders table and its data, we see for each of these clusters carrying the same order ID that the customer ID in all of these cases seems to be unique within these groups. So see this customer ID. And of course, the name behind this customer ID is always the same name. So in case of the name, we are pretty sure that within a group defined by one specific order ID, the names in the respective datasets are all the same. However, if we return to the SQL editor, we do have a problem with quantity. The reason for this is that the values for quantity are not unique within one group. We can verify this by looking at the data of orders. So here you see an example of one group defined by the order ID of this value. So you see all these have the same order ID. As I said before, they also have the same customer ID. However, they don't have the same quantity. So that is 4252. So we have different values for quantity. Now looking at our SQL query so far, recall that because of the group by orders.orderID, all those values which we select over here in the select statement are returned on a group level. So it's easy for SQL to return the order ID on group level, because on group level we have only one order ID. That's how a group is defined. As we have already verified, it's also easy for SQL to return the customer's name, because we have seen that within one group the customer's name is unique. So it's uniquely defined what the customer's name of a group is. However, a problem arises when we ask SQL to return to us the quantity of that group, because now it's not clear which values of these 4 values to choose. So SQL will return one value per group, as you can see down here, because each row here is such a return on group level, but we can't control which value it is actually. So what I want to say is that we cannot ask SQL to return to us the order's quantity. Well, of course, technically we can, but it doesn't have a clearly defined meaning. But before I delete this expression here, I want you to rethink. Is orders.quantity really the thing we want to type here? No, it is not. Why not? Because the exercise said, find out how much each customer ordered in each of his orders. Now, one order is one of these blocks with the same order ID. And the how much information is not one of these quantity values. It is the sum over all of these quantity values within one specific group. And that is something which is precisely defined on group level and which can be written down here in the select statement by using the sum command. So we want to sum over the order's quantity. So suddenly the problem of which one of these quantity values should SQL choose is not a problem anymore. It simply, in a way, chooses all of them and sums them up. Now let's see what we get if we execute this one. There we go. You see sum of orders.quantity. Now I want to verify that we did the right thing by checking one of these groups manually. So let's say we do that first order ID. Well, it's ordered according to the order ID, so it shouldn't be hard to find that Bernie Claude order ID here in the orders table. Well, actually it is this one, and you see it has two quantity values, 8 and 1, and their sum is 9. So let's check back to the SQL editor. Here you see the sum of 9. So this is the number of items Bernie Claude ordered in this order. And this is the number of items Fritz Walter ordered in this order, and so on. So that is the solution for our second exercise. In our next video, we're going to work through some more of these exercises. They are at the core of understanding SQL, and it's important that you understand each single step within them. I recommend that you watch the video, get some break, and then redo these exercises for yourselves. If you need to get the product database, just leave a comment in the comment section and we'll send it to you. So thanks for watching and see you next time.